Welcome to Chris Does Rocks. It's time for Lecture 2 of our Intro to Geology series. We will be covering the birth of geology. That's a little bit grandiose to say the much simpler. We're going to be discussing the birth of geology as a modern science, as it's broadly acknowledged. We typically give credit to James Hutton, a Scottish landowner, but I'm going to take a moment to pull back from that and give a slightly more global view, because geology and all science are actually not bounded by any particular border, race, or gender. And we just should probably go and take a moment to acknowledge other contributors outside the Western European canon. We'll start with Shen Kuo, who was a royal astronomer during the Northern Song Dynasty. While observing construction of several observatories, he encountered what are probably, but we don't have samples from the time to confirm, definitely, fossilized plant remnants, specifically the roots of a bamboo forest. He noted that in the location in the mountains where he was, bamboo didn't grow much, if at all, but that the structures he was seeing were very similar to what were in more low-lying and seaside areas. And he proposed that the only way these bamboo forests could have been there would be if the climate had matched that area at one point, and suggested the mechanism was actually that the mountainous area he was in at the time had once been the low-lying seaside area and had somehow been uplifted. He was also a fan of construction projects on the new lock systems for canals that were becoming popular in his area, and noted their effects on the courses of rivers and waterways. This led him to propose several concepts of geomorphology, the formation and structure, or the topology of landscapes and how they were related to underlying earth conditions, and he discussed sedimentology and soil science, creating a broad classification system that was so useful it was adopted by the Department of Agriculture of his time. Later in years, we will come across Ibn Sina, or as he's known in the Latin-speaking world, Avicenna, who, in addition to being a medical genius of his era, was a naturalist in the Islamic world who wrote broadly about various earth topics. He described the rock cycle of erosion, transportation, deposition, and resolidification. He kind of underestimated what was involved in that last one, but for a guy who had limited access to chemistry or intense industrial equipment to replicate and experiment with, got surprisingly close. He also described two of the three rock types as used in the modern concept, both igneous and sedimentary rocks. He didn't discuss many metamorphic rocks, and the few he did, he tended to simplify down and stick into one category or the other. But still a surprisingly good coverage for everything else. He discussed stratigraphy and the layering of rocks, and how they tended to form very specific sequences in locations, and came up with a proposal for what we now call deep time, where he discussed how the world was likely much, much older than the human race itself, and that we were only a small portion of all of existence. indigenous peoples have also had worldwide their own questions about the world and answers that they've had and developed. Unfortunately, they don't necessarily line up with Western academia, or for complicated cultural, colonial, and racial reasons, were actively suppressed from being included into it. So, broadly, just to say, geology is not a new concept for humanity. It's just only recently been categorized in a way that we would consider it a Western science. So, all of that is aside. We talk about James Hutton as the founder of geology and father of it. I'll credit him more for his popularization and getting people to speak about it in a unified way. He didn't have to invent the idea to have gotten everybody on board with the framework to use it. So, in that, he'll definitely get credit. A lot of people like to discuss how his concepts overthrew the idea that the world was only 6,000 years old. But actually, that was not a historically broadly believed concept. For one thing, it came out of the Christian Bible, which is not used by the majority of the world, even at the time. B, it was not a universally accepted reading by all Christians. It came out of a Catholic pope going and counting generations in the Bible. And that wasn't really somebody that anybody cared about in the Eastern Orthodox or Greek Orthodox Church. They didn't listen to papal law because they weren't part of the Catholic Church there. And then C, the reading that there were only 6,000 years was based on a lot of assumptions that even at the time people called faulty or laughable. So it was really a very small portion of people who actually believed the 6,000 years, but they happened to be fairly influential in church or politics. So going and disagreeing with them made a lot of very public, if not very common, debate. All of that kind of undermining of Hutton aside, he did do some interesting things. While going and observing things around his farm, where he was a landlord, not a plowman, he did come up with observations and suggested that the processes he was seeing were probably not only ongoing processes instead of just what he'd observed for those few hours or years. He also suggested that they were likely to be the same regardless of where or when they happened. The process themselves would still apply, but did acknowledge that they would conform to the conditions in those locations and times. So, if you had a rain on a mountainside, it would probably be much more intense erosion than it would be on a flat plain. But broadly, this concept he suggested was called uniformitarianism and still holds true today, not only in geology, but as a general principle for most sciences. He also came up with the idea the present is the key to the past, in that you could study current processes and their effects on landforms, or rocks in general, and use those to backtrack and figure out where things actually started, how processes came about. Like the idea that if you have a river wearing down the rocks in a canyon, it's likely you can argue that the canyon probably came from the river, rather than the canyon pre-existing, and the river just one day deciding to fall down in it. There was also the debate of Neptunism versus Plutonism as the origin of rocks. Hutton really simplified on his arguments here, but did do good work. Neptunism at the time was the predominant theory, based off of derived from the name Neptune, god of the ocean. It suggested that all rocks on Earth were placed there from either in the deep sea or moved in by a great flood. Again, referencing biblical things as if literalism. Hutton supported, on the other hand, Plutonism, named for the Greek god Pluto, actually Roman, but eh. And it was the idea of from deep in the earth was the origin of rocks, and that they were incredibly hot rocks that cooled over time to form the planet. Hutton didn't go and do a great job on his geochemistry work or anything else, but he did do a lot with speaking with researchers in metallurgy and industrial processes that demonstrated the concept that you could have a solid crust on an otherwise still hot and molten material, and thus why you would see the layering on the Earth. His exact philosophy was incorrect, but his logic was sound. And if he didn't personally figure out all of geology there, he did do an excellent job of convincing people to talk about it and to have consistent discussions instead of everybody throwing out some brand new philosophy every other day. So, James Hutton, as a science evangelist, deserves extreme credit. As the original thinker of all great thoughts, less so. But science is a communal effort rather than the work of any individual one great man. So, I think we can still give him some partial credit on this. Next week's topic will be geologic time, discussing these ideas of deep time, extreme age, and the long ongoing processes involved. I'll see you then.